Okay, guys, welcome back. We're going to continue on with three-phase power factor correction. Okay, and so here I am. I got my alternator here. Okay, Y connected. Now, don't be all messed up by this drawing here. This is our uncorrected load. Okay, this is our delta connected three-phase capacitor bank that's doing the correction. Okay, so because I want you to notice that it says calculate the power factor of the uncorrected circuit. If you want to figure out the power factor of the uncorrected circuit, okay, that's the uncorrected circuit right there. Okay, there's the capacitor bank that's correcting this thing to, I don't know what, looks like 90%. All right, guys. Now, unfortunately for you guys, this is a circuit where I didn't just give you the voltage and the current. You have to actually, just like single phase, guys, if I don't just straight up tell you what the voltage and current is, you're going to have to figure out, the current and the power factor by yourself. All right, guys. So I've given you the voltage, but I haven't given you anything but a circuit here. And look, calculate the power factor of the uncorrected circuit. Now, how the heck am I going to calculate the power factor of this? Well, it's not as hard as it looks, guys, because this is just a RL series circuit. And if I want to know what the power factor of this thing, all I have to do is draw that little RL. It's kind of like test one there, okay, guys, where there was a little RL series circuit there. R is equal to 6. Okay, and XL, which I'm going to draw straight up, is 5. Okay, so don't overthink it. What's this, guys? Z, right? And I'm going to calculate it right now, just for fun. All right, because I'm pretty sure I'm going to need it. Okay, guys, so Z will be 6 squared, right? Plus 5 squared. Root. Looks like it's going to be 7.81. Okay, and that's going to be Z of this, little business right here, right? It's going to be impedance of that rung there, that little branch of our three-phase circuit here. And this will allow me to calculate A, because the power factor, guys, is going to be, well, calculate the angle if you want and hit cos, but I'm going to hit adjacent over hypotenuse, okay? So it's going to be equal to the adjacent over the hypotenuse. I don't need a power phasor diagram to calculate the power factor, right? Any diagram for the circuit will work. And again, this is uncorrected, so you can ignore the capacitors. They're not there yet. Okay, adjacent is 6. 7.81. Let's do that. 6 divided by 7.81. 0.768. Okay, so that's the answer for A. Now, B here, guys, what is the line current after correcting to 90%? Sounds like an innocent enough question, but it's going to take a little bit of figuring. Because in order to figure out the line current after correcting 0.9, I have to draw a uncorrected power phasor diagram and then a corrected power phasor diagram to 90%. And there's no shortcuts, okay? There is no shortcuts. All right, guys? So as soon as I realize that it's a power factor correction question, I'm going to start drawing power phasor diagrams, and we'll start right here. Uncorrected, all right? And I know it's going to look like this, right? And P is here, and VA is here, and VARS is here. Now, lucky for us, guys, we've already calculated one of the things, 0.768, okay? Before correction. It's the power factor. Now, what can I calculate of these three? Well, the easiest thing to calculate, and the thing that you should calculate, is the VA. Well, how am I going to calculate the VA, Van Andel? Well, the VA, guys, is equal to E line times I line times root 3, right? And if I've got E line. All I need is I line. Well, how am I going to calculate I line? Well, I have to figure out, here's E line. I want to figure out E phase. I'm going to do that right now, okay, because you must calculate that. You can't just assume, okay? So we're going to go E phase load here, guys, and it's delta, so it's also 208, right? And the reason I need E phase load is so that I can figure out I phase load, okay? So I'm going to calculate, I'm going to put a little A over here, guys, sort of a step. It's not A, it's step 1, okay? I'm going to calculate the VA, and we're going to do that. I'm going to calculate I phase, okay? load. And I-phase load is going to be the 600 volts, the 208 volts that's dropping across that divided by the impedance of that, okay, guys? So it's going to be E-phase load divided by Z of the load, okay? And E-phase load is already decided, it's 208 volts because it's delta, and Z is 7.81. Okay, so let's calculate that very carefully. 26.63. Okay, and that would be right here, guys, right? 26.63 amps. But my VA formula needs I line, so I actually need this, okay? I line, and so I'm going to calculate that next. I line secondary, really? You know, it's I line load, really, I guess you could say. Okay, and that's going to be 26.63 times root 3 because, you know, it's delta. So I'm going to go times root 3, guys. 46 amps. Okay, so let's just review here. Our goal in life is to figure out the VA of this circuit, because if I have the VA and the power factor, I can finish this drawing, okay? The only way to calculate the VA is to know E line and I line, and I know E line, and I'm working on calculating I line, okay? Now, the only way to get I line is to figure out what the voltage dropping across that is, and then dividing it by, you know, the ohms of that. But you have to remember that what you've calculated there is I phase, okay? I have to take the extra step and make sure that I get I line, all right? And it's delta, so I multiplied it by root 3. Now, this circuit can look like absolutely anything. It can be Y, it could be delta, it could be, you know, something else. You know, do whatever it takes to get the line current, okay? And really, there's no shortcuts. To get the line current, you must figure out E phase load, then I phase load, then I line load, okay? And that's what we did right here. No shortcuts, okay, guys? Now, we've calculated I line. Now I can calculate the VA of that three-phase load. It is going to be E line, I line times root 3. All right, guys. So now you know what I'm talking about when I say if I give you the voltage and the current and the power factor as a word type question, you know, thank your lucky stars, because you don't have to make all these calculations. But if I give you a circuit, you're going to have to do it yourself. We have to calculate our own power factor. And now we're going to calculate our own line current. And now we're going to finally be in the position where we can calculate the VA. And the line voltage is 208, guys. And the line current is 46. And the root 3 because it's three phase. It's going to be 16619 volt amps. All right, guys? I'm just checking this all out here, make sure I'm not screwing this up here. I don't want to do the whole question and realize that I've made a mistake. Nope, that's correct so far. All right, guys, so now we've calculated our VA. Now it's like any other power phasor diagram. I'm going to finish it up. This is going to be VA times the power factor. Okay, so it's going to be 16619 times 0.768. All right, times 0.768. 12764. I guess this could be a 3. Doesn't matter. Watts. All right, guys. And then we'll calculate our VARs. It's going to be, you know, right? 16619 squared minus 12763 squared equals root equals. Looks like the VARs before correction is 10,644 VARs. Okay. come back and we'll do B. We'll continue to do B, C, and D in the next video. Okay, guys? Sorry that this is taking a few videos, but it's a big deal, eh?